So today we are going to be working on a transistor box for the 3D printer. So in two previous videos I've shown you how to augment your 3D printer by adding transistors so you can switch 12 volts around the printer. This time, instead of having multiple transistor boxes throughout the printer running different systems, I'm going to make one big transistor box that runs 6 variable outputs and then have 3 separate constant 12 volt rails. This way you can attach 9 12 volt devices to the printer, 6 of them which can be controlled through analog systems. So there was another recording that I had that showed this similar circuit. I had to replace these with the different transistors because I already made the circuit, but I realized the mic was off on my camera. So now that the mic is on, I can show you what this looks like. So each of these rails is attached together, so I have 12 volts going into the Arduino as the voltage in, and then of course I have ground running across here, and that's mapped to this ground, which is going to be attached to a power supply. Each of the emitters on the transistors, including the small T092 transistors, are grounded. And the base of each transistor is on a pulse width modulation pin on my Arduino. Each collector is attached to its corresponding pin over here. So this transistor is this wire, and this transistor is this wire. So it's a pretty simple circuit, but I am going to show you a demonstration of it working. So first things first, of course, we're going to hook up ground and 12 volts from my bench power supply. And that turns the Arduino on. So the code that I have running in this Arduino has this turn on completely for a second, then it goes to 9 volts, then it goes to 0. And then it goes to this one, does the exact same thing, and then it goes down the list, and then it comes back to this one and does it again. So I'm going to bring some 12 volt accessories up here so I can show you the possibilities of this transistor board. So this is a spare LED strip I have laying around. I'm going to hook up this to a 12 volt rail, and this is a common anode LED strip, so all the grounds change the variances in color. So when you go through the cycle, here, let me just reset the board real fast. Red's going to be the first color, then it's going to fade, then it's going to go to 0, then it's going to go to green, fade, 0, blue, fade, 0, and that's coming from the first 3 pins here. So the Arduino is sending to the base the signal to turn the transistor on, and the collector's output goes to each of the lights. Of course, there's 6 transistors on this board, so I'm going to get 3 more things that use power. So I went ahead and grabbed a multimeter, a fan, and the original light that came on the 3D printer. So after this goes through its 3 transition, this will also work. This fan also works. And because I don't have another 12 volt accessory, I use the multimeters. So this is using 6 transistors on this breadboard to run an entire array of things. And there are at least 6 external outputs on your ramps board that are available for you to hack into and program to make them do things. So I'm now going to compress this all into a printed circuit board. So I'll be right back. Here's all the 6 transistors right here. I've added 2 rails that you can get 12 volts from in case you need to run any external device. These are the logical outputs right here. So there are 8 plus 6, that's 14 outputs in total. 8 which are not controlled, 6 which are, and then I also was able to rip off an old destroyed ramps board, the adapter, and I mapped it the same way as the ones that's already on the printer. So this is now a secondary device that's going to be inside the 3D printer. So before we, of course, throw this in the printer, I'm going to test it out first. So it's the exact same code in the exact same circuit, except it's just soldered to this smaller board now. But this is just me testing the entire thing. I have it set up in the exact same sequence, so all of the individual components still turn on exactly how they did before. And so now I know that this works. I'm going to go put this on the printer now. Alright, so now that I have my 3D printer taken apart right here, this is the transistor box. I'm not going to put an enclosure on it just because I kind of like the way it looks exposed like this. I'm going to put it on the bottom of the 3D printer like this. I'm going to drill 4 holes in the corners where the screw holes are, and then I'm going to be putting these tiny screws in the printer so that it'll mount right next to the ramps board. Alright, so now what I've done is I've put the screw holes in, and now I'll be hooking up to the power supply. I've also crimped some connectors so I can easily put them on the power supply. Alright, so what I've done here is I've taken pins 11, 4, 5, 6, 63, and 59 and mapped them across the transistor board inputs. So now whatever I put as outputs here, I can reference from the inputs from the ramps board. Just to show you an example what this allows me to do, I've set the fan pin from the Arduino to 11, and that's the one you can control from this. So I do have the 12 volt rails on my power supply as well. So this is the fan, whoops, look at that in the shot. This is the fan that cools the ramps board. I can plug this into the 12 volt rail, and it'll turn on constant like it usually does. But what I can do with these 6 outputs now is that I can put it on one of these outputs and then define the input on a code in the Arduino Marlin firmware. So now I'm going to set the fan to 255, and now it spins up. So now I have control on this fan, so I can choose if I want this fan to be off or on based off of constraints that I set in the firmware. So say that if I want this fan to be on only when the temperature is rising on the printer while I'm printing, and then as soon as the temperature drops and I don't need to cool the ramps board anymore, this will then turn off. That way I'm not running all of the fans and it makes a whole bunch of noise. And that's the main reason why I wanted to do this. So I'm going to go hook up my extruder fan, the cooling fans for the filament, this fan, and then the 3 outputs for the LEDs. And then that'll use all 6 transistor circuits. And of course, I still have 8 12 volt outputs from this power rail. So when you turn it on, I was able to hook the RGB LEDs back up. So those are referenced at the top of the case through this wire right here. I also hooked up the fans so that if you change temperature fan speed, these fans will come on. Now, if I turn these off, I've put a definition in where if the bed temperature is requested above 10 degrees, these 2 fans come on. Now both of these yeah, crashed. So after that happened, the printer crashed. I realized that I had too much of a load on the ramps board. The transistor board was working fine. That's why it worked well with the Arduino Uno, but it was only selectively choosing each individual output. I never gave the transistor board during testing a full load, and that full load on the transistor box might actually feed back to the Arduino and prevent it from being able to move all 6 transistors. So I'm still going to have to diagnose that. I'll revisit this video for another day. But this is what I was pretty much working on for my entire month. I planned it to be spectacular, and I was extremely disappointed when, you know, it didn't work. So I basically took the whole printer apart, gave it a new transistor board that it already had. It was just split, so I merged the 2 boards together on a different board, rewired everything, and then as soon as I went to go add something, it didn't work. So I think I'm going to stop modifying my printer. My printer is already performing as well as it needs to. There's no reason for me to seek any more performance, speed, or noise reduction out of the printer because I'm satisfied with it. But I still need to make videos. Well, not really need to. I still want to make videos, but I'm running out of things to do for the R1. Luckily, there's a big box. What's in the big box? Well, the last big box I had was an R1, so that must be an R1 Plus. So I think next month I'm gonna have to unbox it, but I'm gonna wait. It's so hard to wait, but I just haven't had the time to sit in front of the camera and really do much. I was working on the transistor board, didn't do much. That's what I had on recording. But next month, when the entire house gets here and I get to see Robert again, and I'll have the whole crew with me, I'll do the unboxing video. And then I'm going to do a first print, and I might even revisit a friendly competition between my modded R1 versus the new R1 Plus. And then, because this is the channel, I guess, we'll have to modify the R1 Plus, or at least disassemble it a few times. Because, I mean, come on. Who doesn't want to see the insides of an R1 Plus? I know I do. So, again, apologies for the failure in the video. I was kind of recording as I was going along, and I didn't expect the transistor board not to work. I mean, it worked. It just wouldn't work on full load. So that's something I might have to diagnose. If you have any suggestions for how to fix that issue, that would be highly appreciated. Because I want to be able to map all the stuff that I have in my printer with 12-volt switches. I mean, I use TIP31 transistors. I haven't done a lot of research on those. I just had an abundance of them, and because I had so many, I thought I might as well use those. I might need to add capacitors to the board because there's too much of an amperage draw. I might need to separate the outputs. Maybe it's something wrong with the programming. Maybe I just hung up the programming. Who knows? But if you have any suggestions about how to fix the issue you saw in this video, let me know, and I'm going to try to work on that. And then tune in next time for the unboxing of my R1 Plus. See you next month.